Hey everybody, it's your SI for Chem, Sarah, coming at you with some more Chem tips and walkthroughs on how to do these worksheets, like this one for today, 9.2 and 9.3 VSEPR theory and polar bonds. So let's get started. The directions for the first set of problems is writing out the number of electron groups around the central atom and writing out what the arrangement is for each. So here's a little list of the different types, so we're going to use that when we're writing out these. So for PCl6 negative, I'm not going to go over the steps of writing Lewis dot structures. I'm going to assume that you can do it with a periodic table and setting up the number of electron pairs. But in this case, you would get a Lewis dot structure, something like this, and it's a negative here. So that means it's one extra electron to add to your electron pair total and all that kind of stuff. So you'll see that there are 1, 2, 3, 4, 5, 6 electron groups, because electron group is a lone pair or any type of bond. So that means it's 6. And if it's 6, then it's octahedral. So that's why the arrangement's octahedral. So for BeH2, see how it's just an H and H and a Be, it's just 2 electron groups, so it's linear. So that's why that one's a little bit easier than the other. Okay, next one. So for this one, we're looking at what best describes the shape of these compounds, and we're using ligands. So ligands are atoms that are bonded to other atoms, mainly the central atom. So when we're doing HCN, as you can see here, there's just 2, right? And there's just 2 ligands. So it's just linear. I know you can't see that very clearly. I can try to zoom in. There we go. See? Linear. And all that jazz. So that's linear. This is NH3, right? So when we do the Lewis dot structure, we get this. And it's 4 because of the lone pairs here. But there are just 3 ligands because there's only 3 actual atoms. So because of that, it's trigonal pyramidal. Because yes, there's 4 electron groups, but there's only 3 ligands. So trigonal pyramidal. Right there. So now we go on to methane, CH4. And we have 4 electron groups and 4 ligands. So that means we just get tetrahedral. There we go. Okay. Now we're looking at angles between bonds. So the angle between 2 of the nitrogen-hydrogen bonds and this one here, you have 4 H's and surrounded by a plus here. That is a plus. There you go. And so with that, there's just 4 of them. And so that would be a tetrahedral again, because if we look here, their angle is 109.5 degrees. So this means that it's just 109.5 tetrahedral between all of these bonds, the nitrogen and hydrogens. Okay, so then this one is the angle between carbon-sulfur and carbon-nitrogen bonds in SCN. So we know it's linear, right? So that means that all of these sulfur and carbon to nitrogens are all going to be 180. So then this one is talking about carbon-chlorine bonds in the COCl2. And so when we do that, it's 3, right? So then that would be trigonal planar, which is 120 degrees. Yes, 120 there. So that means that they're all just 120 degrees, because this would be 120 and this angle would be 120, so that's why that's the way it is. Alright, so almost to the end. We're writing out what the central atom is, how many lone pairs present, ideal angle, and whether it's smaller or larger. Now see how it says lone pairs, more lone pairs or bonds, the smaller the angle. So that's what we're going to do in ClO2 negative. So here's our Lewis dot structure, and that's what we set up. And we know it's tetrahedral, so that means the ideal angle would be 109.5. We know that the lone pairs present are 2, as you can see circled there. 1, 2. So that's 2, and then we know the central atom is Cl. And because there are 2 lone pairs rather than none, it's going to be a smaller angle. So it's going to be smaller than the ideal. Okay, now this one's a resonance, NO3 negative. I didn't want to write out all the resonance, but you can see that this oxygen here could switch on this side or this side with the other 2 oxygens, and that's what makes a set of 3 resonances. And so the ideal angle would be 120 because it's a trigonal planar, and there's no lone pairs present, so it's 0. The central atom is N, and because there is no lone pairs and not too many bonds, and it's just like a balance equivalent to what you would find in a regular trigonal planar, it is the same. And so the last set of directions that we're going to do is circle if the ion is or molecule is nonpolar or polar, and what atom is most negative. So for this one, the H3O+, we know that the H's are going to be more positive and the oxygens are going to be more negative. So as they're going in, it's going to have this positive on the outside, then arrow to the negative. So that means it is polar, and the oxygen would be the most negative. So then for O2, we gotta know it's diatomic, it's most likely nonpolar, and it really is. It's nonpolar. CO2, also nonpolar because these 2 directions cancel out. And then for HBr, it is polar because this plus and this is negative, so that's going to go into it. It's one direction, yes, but it is polar, and it's not canceled out. So that's why that would be it. And then the Br would be the most negative. So there you go. That is how you handle this worksheet. So if you have any questions, comment in the discussion board on campus. All right.